Let us learn about relations. For example, let us take the set A as 1, 2 and set B as 3, 4. I'm going to write the Cartesian product of these two sets. So this will have 2 into 2, 4 elements. 1, 3, 1, 4, 2, 3 and 2, 4. I'm going to write a set R1. It has all ordered pairs x, y such that y is equal to x square, where x belongs to A and y belongs to B, expressed in set builder form. Now I am going to write in roster form. This is 2, 4. This is the only element which satisfies this condition. Y is equal to x square. So this set has only one element. Now let us define another set as set of all x, y such that y is equal to x plus 2, where x belongs to the first set A and y belongs to the second set B. This has been defined in set builder form. I am going to list out the elements in roster form. So y should be equal to x plus 2. 1 plus 2 is 3. 1 plus 2 cannot be 4. Then 2, 4 satisfies this condition because 2 plus 2 is 4. So this set has 2 elements. Let us define another set as set of all x, y such that x is greater than y, where x belongs to A and y belongs to B. Let us write in roster form. Let us think about the element satisfying this condition. X should be greater than y. 1, 3, no, it doesn't satisfy. 1, 4, no. 2, 3, no. 2, 4 also doesn't satisfy this condition. So it is a null set. Now let us consider another set containing set of all x, y such that x is less than y, where x belongs to A and y belongs to B. Let us list out the elements. X should be less than y. 1, 3 satisfies this condition. 1, 4 also satisfies. 2, 3, 2, 4. So this set has all the elements of A cross B. Now each of these sets is called a relation. Now I am defining another one. Let us consider this relation as set of all x, y such that x square is less than or equal to y, where x belongs to A and y belongs to B. Let us list out the elements satisfying the given condition. 1 square is less than 3. 1 square is less than 4. Then 2, 3 doesn't satisfy this condition because 2 square is 4, which is greater than 3. Then 2, 4 satisfies because 2 square 4 is equal to 4. This relation has 3 elements. If you see, R1, R2, R3, R4, R5, all are subsets of A cross B. So it may be a null set, it may have 1 element or 2 elements or 3 elements, or it may have all 4 elements like R4. A null set is a subset of any set. A cross B is a subset of A cross B itself. So any subset of A cross B is called a relation. Any subset of the Cartesian product of two sets A and B is called a relation. Now this A cross B which we wrote has 4 elements. So how many subsets we can write? We know the formula 2 power 4. 16 subsets we can write. So we can define 16 relations on this A cross B. So each subset is called a relation. Let us learn the definition of a relation. See page number 34, definition 2. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. Now let us consider a relation, a subset I am taking. For example, I am taking 1, 3, 1, 4 and 2, 4. This is a subset of A cross B. Now the set of all first elements. The first elements are the inputs and the second elements are the outputs. A, B, set A has 1 and 2, set B has 3 and 4. 1 is related to 3, 1 is related to 4, 2 is related to 4. So 1 and 2 are the inputs and 3 and 4 are the outputs. The set of all first elements is called the domain. 1, 2. No need to repeat the elements in a set. We usually don't repeat the elements in a set. So the domain is set of all first elements, which is 1, 2. Now range definition. Set of all outputs, the second elements, 3, 4. That is called the range. And codomain. Codomain is the second set itself. This is called the codomain. If you notice, range will be a subset of the codomain. It may be equal to the codomain also. If I consider the element 1, 3, this 3 is called the image of element 1 and this is called the pre-image. So if you consider a relation, the relation can be defined in 3 different forms. You can write a relation in set builder form, or you may represent it in roster form, that is listing out the elements, or you may represent it by arrow diagram. Now if a set A has P elements and set B has Q elements, we know that the Cartesian product of these two sets will have PQ elements. And the definition of a relation is every subset of A cross B is a relation. So how many subsets we can write for A cross B? 2 power PQ. Therefore, number of relations defined from A to B will be 2 raised to PQ. These many relations can be defined. Now, if we write a subset of A cross B, we say that it is a relation R from A to B. Whereas, if we are writing a subset of A cross A, say, we can say that it is a relation R on set A. So if I say relation on set A, it means A cross A. Exercise 2.2. Question number 1. Let A be the set 1, 2, 3, etc. up to 14. Define a relation R from A to A by, the definition of R is given in set builder form, set of all x, y such that 3x minus y is equal to 0, where x and y both belong to the set A. Write down its domain, codomain and range. You should have a clear idea about domain, codomain and range. So here 3x should be y. Let us write the elements in rooster form. If x is 1, y is 3 by this condition. If x is 2, y is 2 3s are 6. If x is 3, 3 3s are 9. For 4 it is 12. For 5 it is 15. But if you notice, the definition says that x and y both should be in A. 15 is not in A. Therefore, we cannot consider this last element. So this relation has only 4 elements. Now write down its domain. Domain is set of all first elements, set of all inputs, which are 1, 2, 3 and 4. Then let us write the range. Range is set of all second elements, 3, 6, 9 and 12. We have to write codomain. Codomain is the second set itself. The relation is defined from A to A. So the second set is A. Codomain is A. Question number 2. Define a relation R on the set n of natural numbers by R is equal to set of all x, y such that y is equal to x plus 5. X is a natural number and it is less than 4, and x, y both are natural numbers, it is given. Let us write the elements in rooster form. X should be less than 4. Less than 4 means x can take the values only 1, 2 and 3. If x is 1, 1 plus 5, y will become 6. If x is 2, 2 plus 5, 7. If x is 3, 3 plus 5, 8. That's all, it has only 3 elements. Depict this relation using rooster form. We have already written it in the rooster form. Write down the domain and the range. Let us write the domain. We know the definition of the domain. Domain is set of all first elements, the inputs, 1, 2 and 3. Range. Range is set of all second elements. The second elements are 6, 7 and 8. Here codomain is not asked. Codomain will be n because the relation is defined on n means n cross n. So the second set is n, that is the codomain. Question 3. A set is given as 1, 2, 3 and 5. Set B 4, 6 and 9. Define a relation R from A to B by the definition of the relation is given in set builder form, set of all x, y such that the difference between x and y is odd and x should be from A and y should be from B set. This is the definition of the relation. Write R in rooster form. Let us list out the elements. The difference should be an odd number. 1, 4, the difference is 3, which is an odd number. 1, 6, difference is 5, odd number. 1, 9 won't come, the difference is 8. Now 2, 4, no, the difference is an even number. 2, 6 is also, difference is an even number. 2, 9. And then 3, 4, the difference is 1, which is odd. 3, 6, yes. 3, 9, the difference is 6, which is an even number. Then the next element is 5, 4, 5, 6, 5, 9, the difference is 4, which is an even number. Question number 4. The figure 2.7 shows a relationship between the sets P and Q. This is called the arrow diagram. 5, 6, 7, 3, 4, 5. 5 is related to 3, 6 is related to 4, 7 is related to 5. Write this relation in set builder form. If you notice, these numbers are 2 less than this. 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5. So let us write it in set builder form. I will name this relation as R. So R is equal to set of all x comma y such that y is equal to x minus 2, where x belongs to the first set P and y belongs to the second set Q. Now the second answer, we have to write it in rooster form. Let us list out the elements. 5 is related to 3, 6 is related to 4, 7 is related to 5. What is its domain and range? We know that the domain is set of all first elements 5, 6 and 7. Let us write the range. Set of all second elements 3, 4 and 5. This domain is P set and range is Q. Question number 5. Let set A be 1, 2, 3, 4 and 6. 5 is missing here. Let R be the relation on A defined by set of all A comma B such that A comma B, they belong to the set A. B is exactly divisible by A. Write R in rooster form. So R is equal to A, B both should be in A and B is exactly divisible by A. 1 is divisible by 1. 2 is divisible by 1. 3 is divisible by 1. 4 is divisible by 1 and 6 is divisible by 1. And then for 2, if you write 2 comma 2, 2 comma 4, because 4 is divisible by 2, and 2 comma 6. Now with 3, 3, 3, 3, 6, 4, only 4 is divisible by 4 in this, and then we have 6 comma 6. These are the elements of R. Now the second subdivision, find the domain of R. What is the domain? Set of all first elements. 1 is there, 2 is there, 3, 4 and 6, which is set A itself. Then the third subdivision, find the range of R. Range is set of all second elements. We have 1, 2, 3, 4 and 6. That is also A. Question 6. Determine the domain and range of the relation R defined by R is equal to x comma x plus 5 such that x belongs to the set 0, 1, 2, 3, 4 and 5. Let us write it in the rooster form. If I take x as 0, 0 plus 5 is 5. If x is 1, x plus 5 is 6. If x is 2, we get 7. For 3, we get 8. And for 4 we get 9, and for 5 it is 10. So the condition says that x should be from this set. Look at the condition, x should belong to this set. So the condition doesn't say that x plus 5 also should be in that set. Okay, so we can have other elements like 6, 7, 8, 9, 10. We have to write the domain and range of this relation. So domain is set of all first elements 0, 1, 2, 3, 4 and 5, which is the given set itself. And then we have to write the range. Set of all second elements, the outputs 5, 6, 7, 8, 9 and 10. Question 7. Write the relation R set of all x comma x cube such that x is a prime number less than 10. In roster form. So x is a prime number less than 10 means it should belong to 2, 3, 1 is neither prime nor composite, 2 is the only even prime number, 3, 5, 7. These are the prime numbers which are less than 10. Let us now write it in the roster form. If x is 2, x cube is 8. If x is 3, 3 cube is 27. If x is 5, 5 cube is 125. And 7 cube is 343. In the second step, write x belongs to that set 2, 3, 5, 7. Question 8. Let set A be x, y and z and set B is equal to 1, 2. Find the number of relations from A to B. We know that n of A is 3 and n of B is 2. So the Cartesian product will have 3 into 2, 6 elements. And we know the definition of a relation. Every subset is called a relation. So how many subsets we can write? So number of subsets. We know the formula 2 power m, which is 2 power 6. 2 power 6 is 64. Each subset is called a relation. Therefore, number of relations defined from A to B will be 64. Question 9. R be the relation on Z defined by R is equal to set of all A comma B such that A and B both belong to Z and A minus B is an integer. Find domain and range. If you take any two integers, the difference is also an integer. So all possible combinations of integers will be there in this set. It is an infinite set. All possible combinations will be there. Now we have to write the domain and the range. A can take any integral value, any integer it can take. So it is Z. Range. The element B also can take any integral value. Therefore that is also Z.